You have a multi-core machine and want to speed up your calculation. Does this mean you must install the parallel package in Octave or the parallel computing toolbox in Matlab and then parallelize your code? Not necessarily. The hard work may have been done for you because the BLAS are already multi-threaded. What does this statement mean? Well, deep inside any linear algebra package are the basic linear algebra subroutines. These go by the names like Saxby for single precision a times x plus y, and have been around since the dawn of the computing age, and they have been parallelized internally by using a thread count variable to break up each routine and spread the calculation among the CPU cores. All this happens without the user making any changes to the code at the top level. Matrix multiply is a perfect example of this. Suppose I want to time Octave using a large matrix multiply for different thread counts. How do I do it? Here is the one-liner that you would put into a loop indexed by the thread count. Note you have OMP num threads as a variable, a bash variable that Octave uses to set its thread count. Then Octave evaluates this matrix multiply line, which measures the time it takes to multiply two 4096 by 4096 matrices 10 times, and then averages. Since Octave does not allow changing the thread count without restarting Octave, we had to make the one-liner part of a shell script. I ran this loop over from 1 to 24. My machine has 8 P cores and 8 E cores and hyperthreading for 24 total threads, and put the results in a file by redirecting standard out. And here is that file. The Matlab one-liner is very similar. This time the line can be executed inside of Matlab. No need to use a bash script. When this runs in a loop, the vector of times can be plotted for each number of threads and compared to Octave. And here is the result. It's interesting that both have a local minimum at 8 threads. Right here, it goes up because, of course, when you have asked for 9 threads, 9 does not evenly divide the matrix, so you can't take advantage of it. And these both peter down to values in 16 threads that are actually a little worse than the 8 threads. I would guess that the 8 FPUs in the 8 P cores are maxed, and hyperthreading is not able to parallelize further. That's all for now.